Welcome to Programming with Professor Caliph. Today I'd like to talk about Java interfaces. Before I get into what those are, I want to talk about what are some of the things that we mean when we use that term interface. So in many cases, it's actually used for how the user interacts with the program. So for example, the term GUI, which you may have heard before, means graphical user interface. We also talk about text interfaces when we're just typing things in a terminal window or a console. This is not what we mean in Java. This is completely unrelated, but we use it all the time in relation to programming. So I want to make sure you recognize that is a meaning of interface. That is not our meaning of interface. Another thing that interface is used for is the public elements of a class. So we'll talk about this is the interface of the class. And what that means is this is how other code is going to interact with our class, because these are the public elements. Now, what we're talking about today is related to that, but it's not exactly the same thing. Then finally, we have in Java the interface, which is a construct that specifies a set of abstract methods and possibly static constants. So class level constants and abstract methods, all of which must be public. Now, this idea of interfaces is fairly closely related to our concept of abstract classes. Like an abstract class, an interface specifies a set of abstract methods that anything that implements this will have to implement. The concrete class implements the interface and must implement those methods. Just as a subclass of an abstract class is going to be used, it has to actually implement the methods that are abstract in that abstract parent class. Third notion, polymorphism works and is really the point of having interfaces. There are some differences, however, between an interface and a class, which is why we have interfaces. First of all, I can only inherit from or extend one class. I'm not allowed to extend multiple classes in Java, but I can implement many interfaces. This can be really useful if I need to have a case where this object is a one thing and it also is another thing, and yes, it is a third thing. I could only inherit for one of those, but I could implement interfaces for the others. Unlike a class, an interface doesn't provide data or implementation. And finally, it's important to note that all of the methods and constants specified by the interface are public, and of course the methods are abstract by definition. So why have interfaces? Well, the point primarily is to provide a contract between a class that's going to implement this interface and code that needs to call that class. It's often used for interactions between library code, some code that is written by somebody, maybe the authors of the language, maybe other people, and the user of the library. Let's think about a button in an application. You have a graphical user interface, standard Windows type application or Mac. A user clicks on a button. Whatever's managing that button needs to call the code that was written by the people who wrote the application. But the button code was written way back before the programmer who wrote the application ever thought about creating this application. So how is this button code going to call the application code? And the answer is an interface. There's going to be a standard interface. For some versions of GUIs in Java, that's called an event listener. But this interface is going to guarantee that the application code implemented certain methods, which allows the button code to call the application code, even though the application code was written maybe years later. Okay, let's actually take a quick look at how we do this, both writing an interface, which you should know about, although you probably won't do it much, and implementing an interface, which you definitely will need to know how to do. So here I am in the folder where we've been doing our inheritance related things. And I'm going to create an interface, a very simple interface that I'm going to call printable. And you'll notice if you start looking at, say, the Java library, that you'll have a lot of things that are sort of, yeah, you can do this with this. One of those that's built in is something called comparable, which says, hey, I've guaranteed I've implemented this method that compares two objects of this type. But we're going to create this printable, which is simply going to say, I know how to print myself to the screen. So let's go ahead and save as printable.java. And we're going to make it an interface. In this interface, I'm going to just define one method, print to screen. So it will be void print to screen, and it won't take any methods. It's a very simple method. Now notice I didn't specify that this was abstract, but it is abstract because it's in an interface. And I didn't specify that this was public, but it is public because it's part of an interface. And really, when it comes down to it, this is all it takes to write an interface. I'm going to specify public interface printable. If I have any static constants that I want to create, I can set those up. And then I simply list my methods. I want to use this interface. I want to actually implement it in some things. So the first thing I'm going to do is go to our student class. And I'm going to add to my extends person implements printable. Now you'll notice that after I put that in, all of a sudden my student is underlined in red. And this makes sense to me because I haven't implemented this abstract method yet. So I'm going to go ahead and do the quick fix, add the unimplemented methods, and it'll put this print screen down here for me. I'm going to do this pretty straightforward way. System.out.println, this. Basically just calling the toString since I have a toString. So let's go ahead and save our printable. I have not saved printable. That's what it's complaining about. Okay, now that we've saved printable, student is all happy. And now I'm going to go to a different thing and implement my printable in my bank account. So now this is abstract, yes, but it could still implement an interface. So printable. Notice, because this is an abstract class, I don't actually have to implement the printable method here. I can, but I don't have to. So notice that my checking account and my savings account suddenly have an error because there's an inherited abstract method from that printable that didn't get implemented yet in bank account. So that's worth noting. If I've got an abstract class, it doesn't have to implement its abstract methods because it's abstract. But if it doesn't, then any subclasses will have to implement those. But we're going to go ahead and just implement this in this one. So I'm going to come in here, public void, what's it called? Print to screen. To screen. And we're actually going to do the same kind of thing, just to print line this. Parentheses, details. Okay. So now we've written the interface, we've implemented the interface. Let's actually use the interface. So I make another file with a main in it. So let's call this interface practice.java, And this is just going to be a class with a main. And I'm going to use it to create a couple of these things that we've set up. So I'm going to set up an array of printable objects. So printable, my array is new printable. Let's just have room for 3 of them. And then I'm going to say, okay, my array at 0 is going to be a student with, actually, let's go with our traditional John Doe at jdoe at something.edu. Make it a philosophy major. They need a few. And we'll make him a freshman. Then my array at 1. We will set up a new checking account. And 0001 with a balance of 100, 1,000, sure, why not? And a monthly fee of 5. And then my array 2, we're going to set up a new savings account with 0002, balance of 500, and an interest rate of 0.1001 because we live in the real world. So I have all of these set up. Now notice this is a printable. I've created 3 different kinds of objects, and student has no relationship. The only similarity between students and checking accounts and savings accounts is they're all objects. They have different immediate superclasses, but they all implement this printable interface, either through a superclass or directly in the case of student. So now I want to do a for loop, and I'm going to go ahead and make it a for each. So, and nice code, actually guessed what we wanted to loop through. And so now I just want to, for each of these, call printable.print to screen. So let's run this. And we see that we printed the student, then we printed the checking account, and then we printed the savings account. And this is the basic idea behind interfaces. Even though these classes are not related to each other directly, we can call this method because they have implemented this interface. That's the point. So before I end this video, I do want to talk for just a minute about how you pick. I'm making a class or interface to be a parent for other objects. Should it be a concrete class, an abstract class, or an interface? How do I decide? If all I need to specify are the abstract methods and maybe some constants, that's all I've got. I don't have shared behaviors. I don't have shared data among my different classes. Or maybe all I'm trying to do is to enable my code to call other code that someone else will write. So I need to set up this contract that allows me to set that up and let my code call their code. Then I need an interface. If I actually have some data that all my different classes need to use, or some shared behavior that I can write here, I want to look at a class, not an interface. But if I also want abstraction, so I've got methods that the subclasses need to implement, because I can have an empty implementation. But if I don't make the method abstract, then the subclasses may choose not to implement it. Whereas if the method is abstract, then the subclasses have to implement it or be abstract. I also want to pick an abstract class if I just don't want to allow people to create objects of this type. They need to make objects that belong to the subclasses, not to this class. In some cases, I may be planning for subclasses, but I can implement all methods meaningfully. So I have a meaningful implementation, and making objects of this type of the parent class is just fine. In those cases, we'll want to go with the concrete class. So, for instance, the person class. We may want people in our directory program who aren't students or faculty or staff. If we have such people, we need to have the ability to make a person. And it makes sense to have a person. Whereas if we think about something like a shape or our bank account that isn't a checking or a savings, a specific kind, those it may not make sense to have. So they need to be abstract, but it's fine for the person to be concrete. I hope you found this helpful. Thanks for watching.